Hello guys, in this video we are going to create an amazing end-to-end multi-AI agent application using LangGraph and AstraDB. Now if you don't know about LangGraph actually helps you to create AI agents in such a way that you'll be able to manage their state, the communication between the agents. It provides you the entire workflow to probably create these amazing AI applications. So in this video also we are going to probably discuss about an end-to-end project. First of all, we will go ahead and discuss about the architecture, what we are actually trying to implement. And then step by step we'll go ahead and implement this with the help of LangGraph. So here the architecture of the project looks like this. Let's say that I'm trying to create a chatbot application which has this multi-AI agent feature which will be able to communicate with each other and it will be able to do multiple tasks. So whenever a user query comes, there will be a start node in LangGraph, and this start node will further send it to router. Router basically means whenever I'm probably putting up a user query, we need to route it whether this user query can be fulfilled after requesting from a vector database or whether it can be fulfilled from an external tool like Wikisearch. Now here, just for an example, I'm considering Wikisearch, but in real world application, you can even implement different external tools you like, right? So Wikisearch is one. You can also use SERP API, to probably do Google search itself, right? So in this example, I'm just going to consider one. And similarly, you can implement with respect to other third-party external tools. Then if I probably consider this side, you'll be able to see that it will do a vector DB search. Now this vector DB is basically getting created by AstraDB. We will try to create this entire vector database in the cloud, okay, in the cloud. And initially inside this vector database, we will be putting some information. The information will be a website page from which we can specifically query, right? We will take some URLs and we will read the entire data inside that particular website, and we will store that all in the form of vectors in the vector database, that is AstraDB, right? And this will be in the cloud platform. Basically it is deployed in the cloud, and I will try to show you the entire configuration and how powerful and amazing AstraDB is. Okay. After we do this specific thing, then the next step will be that we will get the response from this, and then we can integrate along with LLM, along with some prompt engineering, like what we really want to do with this particular response. And finally, we should be able to get our response. And the final node is basically end. So this is the entire architecture of this project. In terms of LangGraph, we are going to use the LangGraph. We are going to implement this entire thing, right? So without wasting any time, let's go ahead and implement this entire thing. Okay. So first of all, you really need to know about data stacks. So data stacks actually provides you the access of AstraDB. So in order to access them, you can actually do vector search for real world Gen AI applications, and it is really powerful. Okay. And already I have made some videos related to AstraDB in my previous tutorials also. So first of all, just go ahead and sign in. So once you probably sign in, then you will be able to see this specific page. Okay. If you have not signed in, so first of all, you need to sign up over there. Here you will be able to probably create databases. Okay. So in order to create the databases, you can actually see over here. I will just go ahead and click on create serverless database. Okay. Now there are two options over here: serverless vector database, serverless non-vector database. But as you all know, we are planning to probably create serverless vector database. Okay. And the reason is very simple. Whatever data we have, or whatever data in the form of text we have, we are going to convert that into vector, and we are going to save in this particular vector database itself. So first of all, I'll click this. I will give my vector database name. Let's say this will be test database, right? And here I will go ahead and select any of the region, and let me just go ahead and click on create database. So as soon as I probably create it, it will take some amount of time. So let this get created. Till then, I will just wait probably to create this entire database, and then we will proceed with the next step. So yes, let me just go ahead and click this and let me start it. Okay, so this is getting created. It is going to take some amount of time. So once it is getting created, I will probably go with the next step. So finally, guys, here you can see that my database has got created. That is text database. Test database. It is a vector database. And please make sure that you keep a note of this database ID, because we will be requiring in order to access this database. Then the next step will be that we will go ahead and create our tokens. Now, in order to create a token, first of all, you need to probably select the role that you are probably going ahead with. So I need administrator user. I will just go ahead and click on generate token. Now this token will be important because with the help of this particular token, I will go ahead and access my database, right? So if you also want to know, you can also download this JSON file. So let me just go ahead and click and download the JSON file. Okay. So now I have my access token. Now my database is ready. Now it's time that we go ahead and start our execution of the code. Okay. So before we go ahead, step by step, I will try to show it to you. Till then, just let me hide my face so that you'll be able to clearly see the code itself. Okay. So here I'm going to use Google Colab. So I will change the runtime. Let me just use any GPU that I want. So I'll just go ahead and click on save. So once I save it, my runtime will be on. Okay. Now what I'm actually going to do, first of all, we will go ahead and install some libraries. So first of all, I require a library like LangChain, install LangChain. Then we are going to install LangGraph. Then along with this, we are also going to install Cachio. Okay. So this Cachio will be important because I'm going to, this will be helpful for me to initialize the AstraDB database itself, right? So I will show you. Because for initializing Cassandra DB, we require this library. I'll show you as we go ahead why are we using this. Okay. So here you can see the installation has already taken, it has already started. Okay. Then the next step after this, so what we are basically going to do is that we are going to import Cachio, and then we will provide the connection of the AstraDB. Okay. So in order to connect to the AstraDB, we will be using this. First of all, the important parameter that I actually require is my AstraDB application underscore token. Okay. Now this particular token, we can get it from over here. So here you can see this token information is basically present. So I'm just going to copy this and I'm going to paste it over here. Okay. So here I'm just going to go ahead and paste it. And with the help of this particular token, we will be able to connect to our AstraDB, right? Then we are going to probably use our AstraDB ID. Okay. That is our database ID. Okay. So we will be using this. I've created this particular variable. Let me go and see this. So here is my test database and here is my database ID. Okay. So this basically becomes my database ID itself, right? Now, in order to initialize this, I require this two information. So I will go ahead and write Cachio.init, which is nothing but, .init, and we'll initialize this particular database. So token is equal to AstraDB application token. And the second parameter will basically be my database ID, which will be equal to AstraDB ID. Okay. So here you can see once I execute this, this will get initialized, and here I've got some warnings, but it's okay. Now we are able to connect to our AstraDB, right? Perfect. Now the next step will be that since we need to develop the LangGraph itself, first of all, I will also install one more very important thing, that is pip install LangChain underscore community. Okay. So let me go ahead and install this entire application over here. Once this is installed, I still need to install some more things like LangChain Groq, LangChain Hub, LangChain LangGraphs. There are some more libraries that we are just going to install. So for that, I will just go ahead and copy and paste over here. And I'll talk about what all things we are basically going to install. Okay. So here you can see, I'll be installing LangChain underscore community. LangChain underscore community, I think it is already been installed. We will be installing tick token. I'll talk about this. We are going to use open source LLM models. So for that, we are going to use this LangChain Groq. Then you have LangChain Hub, ChromaDB, LangChain, LangGraph, LangChain Hugging Face. I will not require ChromaDB because I'm specifically going to use this DataStax DB, right? So LangGraph, LangChain Hugging Face is basically there. So now let me just go ahead and install all these libraries. These are some of the basic requirements that I require in order to start my process. Okay. Now, if you have been seeing my entire LangChain series in this course itself, you will be able to see that I have already discussed about LangChain. I've discussed about recursive character text splitter. So first of all, what I'm actually going to do is that I'm going to read some kind of websites, from that I will try to read the text data and convert that into vector and store it in our vector database, which is present in AstraDB. Okay. So this is basically getting installed. It will take some amount of time. Let's wait till then. Till then I will go ahead and write my other code. So here I'm going to use a text splitter, which is called as recursive character text splitter. And since I told you that the data ingestion, I need to read my data from different websites. So I'll be loading langchain_community.document_loaders import web-based loader. Okay. Then the URL, which all URLs I'm specifically trying to read. So these are my 3 URLs that I'm going to use. One is related to agent, one is related to prompt engineering, and one is related to adversarial attack LLM. Okay. Now what we are basically going to do is that we are going to load the URL. So for this, I will go ahead and write docs is equal to web-based loader. I will give my URL dot load. Instead of just using 0, I will use for URL in URLs. And this is basically going to read each and every URL and probably go ahead with the next step. Then I have automatically, this is the amazing thing, Google Colab provides you all the necessary things that is required. Okay. So here I'm going to use a text splitter. Now, instead of using every time recursive character text splitter, this time I will show you something in a different way. So I am going to use something called as from_tick token encoder. And here we are going to provide the chunk size of 500, and there will be also a chunk overlap. Let's say that I'm not interested in putting any kind of overlap, so I'll keep it to 0. Okay. So this way we will be able to do the splitting. So one assignment that I really want to give you is that just go ahead and explore about this particular function, why this function is specifically used. Okay, the answer is given over here only. If you just highlight this, text splitter that uses tick token encoder to count length. Okay, so tick token encoder uses encoding name as GPT-2. You can just go ahead and see the definition. There is a slight difference between recursive character text splitter using this tick token encoders. Okay, then I'm going to probably do the splitting. My document split, I will go ahead and define this variable, and here I'm going to use my document split underscore documents with respect to docs. Okay. Now before I go ahead and probably do this, I will also go ahead and write one more line of code. That is my document list. Here I'm going to consider item for sublist and docs. I'm going to explore each and every docs for item and sublist. Okay. Let me explain about this specific code, what exactly this does. Okay. So here I'm saying, hey, for item in sublist, then we are iterating to sublist in docs. Okay. And we are just getting the item. Okay. So if you just go ahead and print the document list, you'll be able to see that we'll get all the items that is displayed. Okay. So once I go ahead and execute this, you'll be able to see. Okay. Let's execute this. It is going to take some amount of time. So here it is giving us an error saying that the list object has no attribute page underscore content. Let me just go ahead and check this out, and let me see what is the error that is probably coming up over here. So, okay, it should be documents doc underscore list. Okay. So if you want to just go ahead and print this doc list, you'll be able to see what it prints. Okay. Okay. Again, I'll get an error. So it should be doc underscore list. So in doc underscore list, you'll be able to see what item is basically getting displayed. Okay. So here is all my information with respect to this. See? And then I'm taking this entire information, I'm splitting it. Okay. So this is my entire metadata that I have, right? Then we do the text splitter with respect to chunk size. And then finally we do the, we do the split with the help of text underscore splitter. Okay. Now, once I have this doc underscore split. So if you go ahead and see this, this is my doc underscore split. Okay. Now, if I just go ahead and display this, this is my entire splits that you'll be able to see, right? Perfect. Now, I need to take this content and convert this into vectors by using some kind of embeddings. So for this, I am going to use from langchain underscore hugging face. Okay. Hugging face. And from the hugging face, we are going to import hugging face embeddings. Inside this embeddings, I am going to use hugging face embeddings. Hugging face embeddings. And we are going to use a free embedding technique that is available as an open source, ALL-mini LM, okay, L6 V2, okay. So this name, if you see, this is already available in the Hugging Face. So let's see this, and here you can see it is a sentence transformer, and this basically converts, it maps sentence and paragraphs to a 384 dimensional dense vector, okay. But for this, you also require one very important thing. If I go and click on settings, you'll be requiring a token, right? So this many number of tokens is basically created, right? You can go ahead and create a token, because this token will be specifically used over here. Here you can see in the secret key, I've added a token which is called as Hugging Face, right? Hugging Face API token. So it will be asking for this particular token itself, right? So, or HF underscore token. This token also you can basically specify. So create a token name, provide a token name, whatever name you want, and you should just provide permissions and go ahead and create this. For creating, you can see over here, I will just go ahead and write read, write. Okay, so let's say I want to read. So here I will just provide my token. Let's say my token name is something like HF token. Okay, I will go ahead and create the token. Just copy this token over here and paste it, write this particular key name HF underscore token and paste it over here. I've already done that, so I'm not going to do that. I will just go ahead and execute this, because this is going to ask me the token information over here, and I just need to provide the grant access. So here you can see, once this gets executed, my token will be ready. See, it is asking for grant access of HF underscore token, and here you can see it is now able to read the token itself. Okay. Now the next step over here, what we are basically going to do is that we are going to insert all the vectors that we have actually converted by using this embedding technique, okay, into our vector database. So first of all, I will go ahead and write from langchain dot vector stores dot Cassandra, okay, import Cassandra, okay. So we are going to import Cassandra. And then we are going to probably create our Astra underscore vector underscore store is equal to Cassandra. And inside this Cassandra, we are going to use our embeddings. Embedding is equal to embeddings. And then I have my table underscore name is equal to, let me give a table name like QA mini demo. Okay. I'll just go ahead and write this. I will keep my session as none. Now what this is basically going to do is that it is just going to insert my data in the database that I've actually given. Okay. So this will basically be none. Okay. So almost done. Any parameters has been left. Okay. I have to remove this bracket. Okay. Now this is done over here. So let me just go ahead and execute this. Now this will get connected to my database along with this embeddings, okay? And the table that I'm actually going to create is this particular table name. Now inside this table, I need to just go ahead and store my data, right? So first of all, what I will do is that I will go ahead and import from langchain dot indexes dot vector store. I'm going to import vector store index wrapper, not creator, index wrapper, let's say, because this will be a wrapper on top of the vector store that we have created, the Astra vector store. This will be my vector store itself. To probably I can use it to query my vector database. Okay, so let me delete this. Okay, vector store index wrapper. Now I can use this Astra underscore vector underscore store dot add underscore documents, And here I'm going to basically use doc split. Okay. Then I can go ahead and print inserted modulus I headlines. How many records I'm basically inserting? I'm just putting that particular information over here. And here I can use percentile length of the doc split. So this is basically after insertion, how many records has been inserted. Okay. So I'm just going to print this entire thing. Inserted, print, inserted records. Let me just go ahead and see whether I've done any syntax issue over here. Yeah, so docs underscore split. Perfect. Right. So now it is fine. Now I'm going to use this extra vector d vector index. And after insertion, if I really want to access this, I will be using this vector store index wrapper, and I will be using this Astra vector store. Okay. So let us go ahead and execute. First of all, it will just go ahead and insert it. Let's see, vector store index wrapper from LangGraph cannot import the name. The reason is very simple. Here I have made a spelling mistake. Okay. So here also I have made a spelling mistake. It should be S capital. So now let's go ahead and execute this. This line of code is basically going to insert all the documents, right? And then on top of this, I am creating a wrapper using vector store index wrapper. Because of this wrapper, you will be able to interact with the vector database. Okay. So here you have this entire thing. Okay. And now let me show the next step. It is obviously true that you cannot just use directly vector database or this particular variable to access the vector database. Yes, you can use it, but on top of it, we'll try to create it as a retriever. So here I'm going to define my retriever is equal to Astra vector store as retriever. Okay. And then I can go ahead and ask any question that I want. Retriever dot invoke. Let's say I will go ahead and ask, what is agent? Okay. And let me just go ahead and execute it. There's an error, no worries. Okay. What is an agent? And this is my entire answer, right? Building AI agents with this. See, it is basically coming from the vector database itself. When I probably use this retriever, right? And retriever is basically created on top of Astra vector store, right? Which is basically referring to my vector database. Perfect. So if I go ahead and see this part, I have actually created it, right? This entire part of AstraDB configuration, inserting the data. And if you also go ahead and see over here, right? Over here, if I just go ahead and execute it, see the amount of data that has been put up, right? So here is my QA mini demo default key space, right? All the data is basically available over here. I'm again reloading it so that you'll be able to see this. If I go ahead and click this, you'll be able to create a collection. You'll be able to see this, all the information over here, right? And this is great. Just now you did a query and these are all the information that you are able to see. Perfect. Now, the next step, obviously, if this is completed, I need to create wiki search. And for creating wiki search, I really need to go ahead and probably create and use an external tool that is called as wiki search. Okay. Now, before going and creating this wiki search tool, what I'm actually going to do is that I'm going to define a router function. Okay. And if you are seeing my LangGraph videos, I think you should be knowing how to probably go ahead and create it. So let's start working on our LangGraph application. So here I'm going to basically write LangGraph application. Here, three important things we are basically going to import. Okay. One is from typing import literal. From langchain underscore core.prompts, we are going to use chat prompt template, and from langchain underscore core, we are going to use base model and field. This will be important because when we are basically using or creating our route query, we have to inherit this base model. So here, let me just go ahead and create my data model. So here I'm writing class route query base model. Here I've used data source as two important things as a literal, right? One is vector store, one is vector wiki search. Because this route query class needs to route on any one of them, whether it should go to vector store or wiki search. So given a user question, choose to route it to Wikipedia or a vector store. Okay, so that is the reason we are basically using this particular route query. So let me just go ahead and execute this, because after this, we are also going to create some functions. Now, if you are familiar with already working with chat Groq and all, so here what I'm actually going to do is that I will go ahead and initialize my, use my Groq API. So for Groq, I will just go to groq.com. Okay. Inside this groq.com, you need to sign in. And here you can see that it provides you most of the open source model in the form of APIs, right? You need to use the access token and you should be able to use any of this. Even Llama 3.1 is also available. Okay. So first of all, I'll click on start building. I will go ahead and see my Groq API. So I will go ahead and create my API token. So here you can see API keys. You can just go ahead and click on API key, give us some name, and you should be able to create it. And once you get the secret key, you need to update this in the secret key. So here you can see I have already updated it in the name of Groq_API key, and this is my API key, right? So with the same name, you can go ahead and call it, right? Now from this Groq, I'm going to use my model that is nothing but Llama 3.170B versatile or 8B instant. Any one of them you can specifically use. I will use this, okay? And let's use this. So before using this, first of all, we need to import or get our Groq API. So here I will go ahead and execute this. Before understanding one thing, that if I really want to access any secret keys from the Google Colab, I need to import from Google Colab, import user data, and then I'm using user data.groq API. So if I just go ahead and print my Groq_API_key, you should be able to see my API key, right? Grant access, and here you can see. Now if you go ahead and see in the secret key, the same API key it is basically referring to, right? So here is my entire API key that you will be able to see. Then we will go ahead and initialize our LLM model. So for initializing it, I will write LLM chat Groq, okay? And here I'm going to use Groq_API_key is equal to Groq_API_key, okay? And second parameter, I need to give my model underscore name. This model underscore name, we will go ahead and initialize with Llama 3.1. Let's see whether I should be able to copy this or not. Llama 3.1 70B. Let's say I'll go ahead and write over here Llama 3.1, okay, dash 3.1 70B, and this is last is versatile. Okay, please make sure that you have the name same, otherwise it will not be able to call. Okay, now if I have this, what I am going to basically do is that I will just go ahead and use this LLM model. Okay, we'll just go ahead and print this and see whether we are able to call it or not. So here you can see I'm able to call this particular model, which is amazing. Okay, now one thing that you should know is that our router, this router is really important, because based on a user query, I need to give it to vector store or wiki search. Okay, so now what we are basically going to do is that we are going to integrate this route query with our LLM model also. Now how do I do that? So see, at the end of the day, whatever output that I'm actually getting, it should be in this particular format. So here I'm going to create a variable called as structured LLM_router is equal to LLM dot with structured. So there in the side the LLM, there is something called as with structured output, and I'm going to use my route query over here. Okay, I'm basically going to call my route query class. Okay, now this is fine, perfect. Now let's go ahead and check whether everything will work or not with respect to our route query. Okay, route query basically means what? Whenever we get any user query, it should be able to tell whether it is a wiki search or vector DB search, right? And for that, we have also used one LLM model and we have used one route query inside it, right? So first of all, what I'm actually going to do is that I'm going to use one prompt. Okay, so let's say this is my prompt. In this prompt, I'm writing, hey, you are an expert at routing a user question to vector store or Wikipedia. The vector store contains document related to agents, prompt engineering, and adversarial attacks. Use the vector store for the question on these topics, otherwise use wiki search. Okay, so that is what we have written over here. Okay, and that is the reason we have used this chat prompt template from message. We have used system because this is the instruction that I need to give to my LLM model. And here we are giving the question as with respect to whatever human question is basically given. Then we will go ahead and create a variable which is called as question router Here I'm going to use the same route prompt and structured LLM router, because this entire task will be done by an LLM model itself, right? So once I execute this is done, right? Now I will go ahead and write print question underscore router dot invoke, okay, dot invoke question underscore router dot invoke. Let's test it, okay? So I will just go ahead and write a question. Let's say the question is, what is an agent? So if I'm writing what is an agent, obviously my answer should be, it should route it to what? Vector store, because my vector store has already all this particular information. But what if I write a question which looks like this? Who is Shah Rukh Khan? Shah Rukh Khan is a famous actor in India, right? So if I go ahead and execute it, you'll be able to see that it is going to Wikipedia search, because that kind of information is even not present in vector store. So I don't need to probably push this particular query to my vector store itself. It should probably go to the wiki search. So this part of vector store I've already created, right? I've created a retriever. Now what is pending is basically for this Wikipedia search, right? Now how do I probably go ahead and create this Wikipedia search? So again, in LangChain, you have this third party tool in Wikipedia. And for that, we need to install this, right? We have something like archive of Wikipedia, but I'll just go ahead and install Wikipedia, and I'll also install LangChain underscore community. Okay. So here you can see it is already been satisfied. So it is getting downloaded. Okay. So LangChain underscore community, we have already installed it, I guess. No worries. Okay. Now for Wikipedia, I will probably go ahead and import, because here we are working with external tools, right? LangChain underscore community dot utilities. I'm going to import Wikipedia wrapper, Wikipedia API wrapper. Now, along with this, I'm also going to import from LangChain underscore community dot tools, import Wikipedia query run, right? We're going to import both this. Now, first of all, I will go ahead and create my API wrapper. And this entire thing will basically be responsible in probably running my entire queries, right? So whenever I give a query, when it is going to the Wikipedia search, this API wrapper will make sure that it will do that. And here I will just go ahead and define my variable wiki. Okay. Inside this, I can also go ahead and write my how many results I want. Let's say if I go ahead and write top k results is equal to 1, and the max to max document content character max, I say that, hey, I need 200 characters. Okay. And then I will be able to use this Wikipedia. So once I execute this, you will be able to see that if I go ahead and ask any question, if I go ahead and write wiki dot run, okay, and let's say if I go ahead and write tell me about Shah Rukh Khan, okay. So I should be able to get all the response from the Wikipedia itself, right? So all the information is an Indian actor, film producer who works in Indian cinema. So 200 characters, you'll be able to see this. So this in short is basically querying the Wikipedia itself, right? Now my turn is basically to create a graph, right? So we will go ahead and create graph, or we'll go ahead and create AI agent application using LangGraph. Because if you understand from our architecture, we have also developed this. We have also developed a router. Now it's like we need to connect this in the form of graph, right? Like how this graph is entirely there. So let's go ahead and do that. So AI agents application using LangGraph. So first of all, I will go ahead and create one class. Let me just go ahead and create one class. So here I have from typing import list, typing extension import type date. So I'm going to create a graph state, which will be my class, which is inheriting type dictionary. And this will be in the form of key value pairs, like question is equal to str, generation is equal to xtr, and documents list of str. Okay. So I'm basically creating 3 variables. This 3 variables will be responsible in managing the entire state of the AI agents that I've actually created. So it represents the state of a graph, attributes are this many things. Okay. So for right now, just keep a note of that. Okay. You'll be able to understand once we start this. Okay. Now, let's do one thing. Let's say whenever I ask, or whenever a query is basically coming, whenever we give that query to the vector database, Then for that particular vector database, what we really need to do is that we need to probably retrieve from the vector database and we need to give the response. Okay. Whenever we get a response, that will basically be stored in this documents. Okay. In this document variable, and whatever question user is basically asking, it will get stored over here. Right. So here I'm going to probably go ahead and create from LangChain. I'm going to import .schema. I'm going to import something called as document. Okay. Then I will write definition retrieve. Let's say I'm going to take some state over here. So this state that we have defined, it will be a type of this graph state, which will have this 3 information. Okay. And when we are calling this retrieve, we are just going to give that particular parameter. So here, what we are basically going to do, I will just write down some of the comments so that you'll be able to understand what is happening inside this function. So here you can see state dictionary, the current graph state, and returns a state dictionary itself. Okay. So here, what I'm actually going to write, I'll go write print retrieve dash. Okay. I'm just going to write this print, and then let me quickly go ahead and write my question. Question is equal to obviously the question of state, which should be coming from this, because the state, which is a type of graph state, will be keeping in a node of the question. So we are going to probably consider the state over here, and then we are going to go to the next line. Here we are specifically going to do the retrieval. For doing the retrieval, I will go ahead and write documents is equal to retriever dot invoke, and here I'm going to use the question. Okay. Now let me just go ahead and return the documents colon documents, whatever documents we are going to specifically get, comma. So this should be my questions over here. Okay. Oops. Questions. Okay. And the second parameter that I'm going to retrieve is basically my question, which will be equal to this particular questions. So this is what we are specifically returning. Okay. And just through this, you'll be able to see this. Okay. So overall, I hope you are able to understand what we are basically doing with this retrieve. Retrieve basically means we are just going to query it from the retriever and we are going to just display it. Okay. So I hope everybody was able to understand. Okay. There was some indentation issues. No worries. I will just use this. Let's see. It should be fixed. Okay. Perfect. So now it gets executed. So retrieve function is basically done. Now, similarly, I will go ahead and do it for the Wikipedia search. So for that, I can just copy and do this. So for Wikipedia search, there will be a functionality where I take the same state. I will write print Wikipedia over here. No need to print hello. I'll take the question. I'll print the question over here. Then we'll go ahead and write wiki.invoke query of question. And then whatever docs I'm actually getting, that is my wiki results. I'll convert that into document. And I hope I have imported the document also. So this should be imported now, right? And now this finally, I'm probably doing the Wikipedia search and converting into a document and returning back all the results. Okay. So perfect. So what all things have been implemented? We have implemented this functionality. We have implemented this functionality. We have implemented this functionality. Even the LLM part also we have implemented along with the prompt engineering. So in short, why do we say multi-AI agents? Because here they are multi-agents. One is communicating with the AstraDB, one is retrieving the result from there, one is doing the Wikipedia search, and all of them are interacting with each other. So finally, now it's time that we go ahead and probably do all these things. But one thing that we missed out, right, over here is with respect to the routing functionality, because that routing functionality needs to be also defined as a function, right? So here I will just go ahead and define this. Let's go ahead and do this. And I think you should be able to get this. I'll be getting state of question. I'll say question router.invoke this one. Okay. And where do you get the question router? So question router, we have already created it earlier, right? If you remember, we have created over here question router. So we are going to use that question router over here. And here only you'll be able to see that we are just writing this particular question. And I'm saying if source.data source is wiki search, then we return wiki search. Otherwise it is vector store, we return vector store. So all the functionalities, the chunk of functionalities of all the nodes has been created. Okay. Now it's time that we start creating our entire LangGraph flow, right? So I'll write from LangGraph dot graph import end. Then you have this state graph. Then you have this start. Okay. Start. Now, the first thing is that I will start my workflow. I will go ahead and write workflow is equal to state graph. And here I'm going to use my graph state. Whatever graph state I've actually defined, that is my default class. Okay. Then we will go ahead and define the nodes. What all nodes you have over here? Main important nodes. One is the wiki search node and one is the vector DB. Now, in order to create the nodes in LangGraph, I will just go ahead and write this one. Workflow.add node wiki search. Then you have this retrieve function. What is the function name? You can see over here, retrieve. Okay. So I will just go ahead and write this name because the spelling is wrong over there. So I will go ahead and define this. Okay, no worries. So here, one node name is wiki search. The functionality is this. Then I have add node. I'm adding retrieve, which is the functionality is this. Okay. This is basically do the web search, that is Wikipedia search. And the other one is basically to do the vector search. Okay. Now I'm going to build the entire graph. This is amazing. This is just amazing. Okay. Workflow dot add conditional logics. So here I'm also going to go ahead and add conditional logics because this conditional logics will be really important. So sorry, add conditional edges. Okay. Should not be logic. So first of all, we start with start. Then we go with our route question, right? So here I'll just go ahead and define my route question. And you know, in route question, what is basically going to happen? It is going to go in this two terms, right? One is wiki search colon, and then I have this wiki underscore search. Okay. And the second one is nothing but vector store. The vector store will go to my which node? See, this will basically go to this particular node. This node is defined over here. Vector store should go to my retrieve node. So here I'm going to basically go ahead and define my retrieve node. Done. Now this is my route question. Okay. So we have started it over here. We have put a conditional edges saying that when we are routing, whenever this function is hidden, it should either go to wiki search, that is this, or this particular node, that is a retrieve. Okay. Then after completing this, what is the next step is that we go ahead and add workflow dot add underscore edge is nothing from retrieve. Where do we go after probably if we complete this? Retrieve, where do we go? See over here, after we do the retrieve is basically done from here. We go to our end stage, right? So end stage, we'll go ahead and connect it. So here I'm going to basically connect my end stage. And then I will also go ahead and write workflow dot add wiki search should also be going to the end stage, right? Now, finally, we do compile this entire graph. So I will write app is equal to workflow dot compile. Okay. And now this entire compile will happen. Route question is there. Let's see. Okay. I have to give comma over here. Then only it will work. Okay. So let me just go ahead and execute this. So route question here, two options I've given them. Then over here that I have this entire workflow and all the compilation is specifically happening. Now, in order to just display this entire graph, I can just use this image and display from IPython display, right? And this is what is the function app.getGraph.draw mermaid PNG. So this I probably saw from the documentation. So here you can see start, vector store, retrieve, otherwise Wikipedia. And in between, there is something called as router also. That router is not getting displayed, but the entire flow will happen in that way. Okay. Now, in order to execute and see how things are basically happening, you can actually check this out. Okay. And you will be definitely able to see this. Okay. So I will just go ahead and print one of the code. So here you can see what is the agent I'm asking the input. I can add multiple inputs if I want. So I'll say for output in app.stream inputs, for key value output items, I'm printing the key. And then we are printing the document of 0.dictionary.metadata.description. You should be able to get the answer. So once I execute this, here you can see building agents with LLM as it is control. So when I ask this question, this is saying, hey, route the question to RAG, that is retrieve. This is the what is I've printed it over there, right? And finally, I'm able to call this node retrieve function. And finally, I'm getting the output. Similarly, if I go ahead and ask some other question, let's say I ask a basic questions like Avengers or something, some movies, right? Here, my question is Avengers. And if I just go ahead and print the same documents, you should be able to see now it is routing to Wikipedia search, right? So this was about this amazing end-to-end LangGraph applications, basically a multi-AI agents where we have added conditional edges. We have seen how each and every node functionalities will be created and many more things. So I hope you like this particular video. Definitely go ahead and check it out with respect to AstraDB, because this was quite amazing. Because of this, we are able to do this also, and the vector database search that we are able to do with the help of Retriever, it was possible. And again, here we have used Groq, and the entire application has been basically created, right? So this was it for my side. I hope you like this particular video. I will see you on the next video. Thank you. Take care.